Okay, so for tutorial 10 question 3 ni pula you need to know. This one is very important also. I forgot to point out just now. I'm so sorry, but this is on page 7. Okay, so for this question pula, I only did the first two. Okay, so for this question pula, they say it's a second order first of all. And then they give you the feed stream containing, so this is my CA naught. And then this is my volumetric flow rate and consists of 3 CSTR connected in series. So you want to determine the XA for all 3. Okay. Then so it means that CA. So this one is the one that I just now say. Yeah, you need to know. Okay. So since the second order, and you know that this is equal to each other. So you can actually equal them. So V, which is given. So this is my first one. This is my first CSTR. And then after that, over 2 over 5, because this volumetric flow rate actually remains constant throughout the whole thing, and we just assume that. Okay. So then we have 1.5 minus CA1, which is my outlet here, which is unknown. CA1 over there. And after that, we basically substitute, and we have our K pun that we can substitute. So K is from this one. Okay. And then basically we solve using quadratic. Over here we can see that this is our ax square plus 2ab plus basically minus, it's actually like, yeah, okay, you know what I'm trying to say lah. So we are basically solving for CA1. Okay. Now when we solve for CA1 already, we can directly substitute into this equation. And this equation is actually our CA equal to CA naught 1 minus XA. Then it becomes CA CA naught. Okay, no, actually we expand first. A naught minus CA naught XA. So it becomes CA minus CA naught over CA naught equal to XA. Okay. And so this is my CA1, which I just found. Terbalik, sabar. Oh wait, yeah, this is negative. There's a negative here. So it's a negative here, and so it's a negative here. So it becomes, when we terbalikkan, becomes a positive CA naught minus CA over CA naught. That's my XA. Okay. So this one need to remember also. So that's where we substitute for this one. Okay. So again for this one, now for this one, take note that we are first of all looking at a different this one already. It's a different one already. And second of all, it means that my inlet becomes CA1 and my outlet becomes CA2. Like this one is CA0 and CA1. So this one is CA1 and CA2. Okay. So we just substitute like normal, then we solve for CA2. Then we can then substitute CA2 into our basically this one lah, this thing here. Okay, can just substitute into that. So that's for, I didn't do the third one, but I can try doing the third one. So that's for this question. So this question basically mainly you use in terms of tau first, then you find your CA first, your CA outlet first. Okay, then you find the conversion. Okay. So mainly, all in all, for topic 5, and the ones that you really need to take note is this one. And remember, you asked me how to memorize all of this, and basically, the ones that you memorize is this one, and this one, these two, the one I show. And this one. Okay, actually the second order one, most probably you don't have to memorize. Most probably if they give second order means using graph. Or the main ones are That's why I say you don't really need to memorize. It's basically the tau is equal to V over V naught. Your FA naught XA is equal to minus RV. What else? Your CA is equal to CA naught 1 minus XA. Okay, so this one you can relate them with each other because of the XA. Is there anything else? What else? Okay, oh yeah, this one can also be equal to CA naught V over naught. This one, this is FA naught. Okay, so why this one I say is relevant? And because when you derive this one, you solve, you can actually obtain a tau K. Okay, this K comes from this one, and then this XA, so you get this one. Basically, you get this one. Hold on. You will get this one, PFR for this one, okay, and CSTR for this one, okay. And then take note that PFR and batch for my first order, these two are the same, but I get different values. This is actually my tau, this is actually my time. Okay, so do take note for the difference for batch reactor and CSTR, and plug flow. And then for CSTR is the one yang paling odd one hour. Yang ni semua akan kena, this one and this one kena integrate. This one directly I can just straight away use this one. Okay, this remember is for CSTR. For plug flow, it will be FA naught DXA minus R dV. Okay, and then for this DXA, I actually get it from here. CA, again I use this one. CA is equal to CA naught 1 minus XAN. Then I substitute the D. I substitute my differentials. So D CA naught minus, I'm writing, D CA naught XA. Okay, so this CA naught is straight away 0 because constant. So basically the difference in my initials itself is 0, so straight away 0. So it means that I get DCA is equal to minus DCA naught XA. So now what I want is this one, kan? So since that's what I want, straight away I can take DCA, I bring this to the other side, this negative sign, and then CA naught over CA naught is equal to DXA. So this I substitute into here. Okay, so if you want me to show you the whole derivation and just inform me, then I'll just take another video. Okay.